Is it visible screen? Anyone, can you tell me? Screen is visible for you?
Yes, sir.
Okay. This is what I am showing now. This is the steam tables. So we are having two forms of the steam table. One is the temperature base. You see, saturated water and steam at particular temperature. You see, first column only you are having temperature corresponding to particular temperature. We are going to find out the properties of the steam. Okay, for example, so the property of the steam at, you see, this is the temperature. In the first column, it is temperature. Property of a steam at 40 degrees Celsius. You see the 40 degrees Celsius, and we are having different column. Okay. One is the corresponding pressure. Immediately after the temperature, we are having pressure column. Okay. So at 40 degrees Celsius, the pressure is 0.07375 bar. Okay. Next, and we are having the different properties like specific volume, specific enthalpy, specific entropy. Okay, these are the properties. Okay, already you know the difference between volume and specific volume. Volume is going to express in meter cube, whereas specific volume is going to express in terms of meter cube per kg. Okay, these are the two things. Water and steam. Okay, VF and VZ. Okay, today I'll explain what is specific volume in the theoretical part. The specific volume of water at 40 degrees Celsius is, okay, see, I put 40 degrees Celsius, it is 0.008 meter cube per kg. Okay, and for steam, the volume will be more, and it is represented by symbol Vg. You remember Vg, and this is Vf. Specific volume of steam at 40 degrees Celsius is 19.546 meter cube per kg. Okay. Next, already studied HF, HFG, and HG. HF is sensible heat. Okay. Sensible heat is, it is the amount of heat required to convert 1 kg of the water at 0 degrees Celsius to 1 kg of steam at 100 degrees Celsius. That is at saturation temperature. That is called as sensible heat. HF, you see the third column is HF. This one, HF, we are going to express in terms of kilojoules per kg. So at 40 degrees Celsius, it is 167.5 kilojoules per kg. And HFG, okay, it is called as latent heat. Okay, so latent heat is, it is the amount of heat required to convert 1 kg of water at 0 degrees Celsius to 1 kg of dry saturated steam at saturation temperature, that is at 100 degrees Celsius. So at 40 degree, it is 176.7, 2460.9. Okay, this is HF, and we are having HG. This is called as the summation of HF and HFG. It is steam. Okay, it is represented by HG. Then how we are going to define the total heat of steam? Okay, total heat, it is HF plus HFG. It is the amount of heat required to convert 1 kg of water at 0 degrees Celsius to 1 kg of dry saturated steam at saturation temperature. Okay, so you see, next we are having entropy also. Okay, so the advantage of steam table is that we can find out the entropy also. The water is represented by SF, and for this one, evaporation is represented by SFG, and steam is represented by SG. Okay, once again, SG is, it is a summation of SF plus SFG. Okay, so corresponding to same thing, it is expressed in temperature. Okay, same. Okay, first column and last column are same. Don't worry about this one. Okay, we have to concentrate on these properties. This is called as temperature based table. From 0 degrees Celsius to, we are having up to 374.15. Okay, so this much range we are having. Corresponding to temperature, we are going to find out pressure, next specific volume, enthalpy, and entropy of the steam. First table is based upon the temperature based table. This is the table one. So I have shared this table in your Google Classroom, so you can go through and you can analyze the properties. Already I have shared this steam tables in Google Classroom. Okay, next we are having the pressure based table. Okay, so table number 2. pressure based table corresponding to particular pressure. We are going to find out the properties of the steam. Okay, and the pressure, it is in terms of bar 0.006 0.000 bar 2. We are having the pressure up to, you see, up to 221.2 bar. Okay, they used to us find out the properties of the steam at 10 bar pressure. Okay, for example, 10 bar pressure. 10 bar pressure, just you have to go through the steam table where is 10 bar pressure. Okay, so 10 bar is here. You see, you have to go through the first column. Okay, so 10 bar pressure is this one. Okay, 10 bar pressure. 10 we are having 9.8, we are having 10, 10.5, like that. So particularly at 10 bar pressure, the corresponding temperature is 179.9 degrees Celsius. And remember that it is above saturation temperature, and the state of the steam is in superheated condition. Okay, so based upon pressure and temperature, easily we can tell that. So the condition of the steam at 10 bar pressure, temperature is first, second column is temperature, it is 179.9 degrees Celsius. And these are the properties, like Vf is specific volume of water. Okay, at that corresponding pressure. See, we are having the heading like this. First one is absolute pressure in bar, temperature in degrees Celsius, specific volume in meter cube per kg. So first column indicates water and second column indicates steam. And we're having specific enthalpy in terms of kilojoules per kg. We're having HF, HFG, HG. So one is sensible heat, and second one is the latent heat, and third one is the total heat. Okay, so corresponding to 10 bar pressure, go to the 10 bar pressure. That is first column, and sometimes they will give the pressure in kilopascal. Okay, because all the units are in bar, you have to convert that pressure in kilopascal to bar. At 10 bar pressure, we are having saturation temperature as 179.9 degrees Celsius, and this is Vf, and this is Vg, and this one is Hf. 762.6 kilojoules per kg is Hf, and this is a latent heat HFG, 2013.6 kilojoules per kg, and this is a summation Hg, that is total heat. You have to add 762.6 plus 2013.6 is 2776.2. Next, we are having the entropy, specific entropy of water as 2.138. What is the unit of entropy? Anybody? Already you studied entropy. What is the unit of entropy?
Sir, kilojoule per kg Kelvin.
Kilojoules per kg Kelvin. What is the formula for entropy? What is the formula?
Heat by temperature.
Now, how? Ts is dq by t, right?
Yes, sir.
According to our
It is.
formula, correct. What we said is correct. Okay, it is specific entropy said. Okay, separate gas only entropy is kilojoules per Kelvin dq by t. If it is specific entropy, you have to get
Per mass.
per mass. That is kilojoules per kg Kelvin. Correct. Okay. So this is how to see the properties of the steam in the steam table. Okay. In the main exam, they'll provide the steam tables. Okay. So you have to go through the values. You have to find out. Okay. Understood? Steam tables will be provided in the exam. So whatever I give, this kind of table, you will get it hard copy in the main exam. So using this steam tables, we can find out. Mainly remember, we are having two forms of the steam table. One is temperature based and another one is pressure based. Okay, understood? Okay. Now I'll go through the concept. Okay.
Yes, sir. But independent items of science is there. Okay.
Okay, steam. Already we are discussing with the steam. Steam is the vapor form of water. Okay, a screen is visible. It's another screen. Okay, I shared another screen. Is it visible?
Yes, sir, it is
Okay.
visible.
So steam. When you will get the steam? When you heat the water. So there will be evaporation takes place at 100 degrees Celsius. Okay, steam is the vapor form of water. So it is mainly used in different process industries like chemical industry, sugar factories, pharmaceutical industries, and it is also used in power generation, mainly in steam turbines, in steam power plants. Okay, steam is generated in a closed vessel. Uh, Device called as boiler. Already studied different kinds of boiler in elements of mechanical engineering. Okay, we're having Babcock and Wilcox boiler and Lancashire boiler. Okay, so steam is generated in a closed metallic vessel. Whatever the steam generated in the boiler, okay, is going to enter into the blades of steam turbine. Okay, where work done takes place, the power is generated. Hence, the steam play very important role in almost all the industries like chemical, sugar, pharmaceutical, etc. Okay. Now, already you know the pure substance formula. It is a substance in which it retains its chemical composition irrespective of the change in phase. Okay, so there is no chemical change takes place within the system. Already we studied the formation of steam at constant pressure. Okay, so these 5 diagrams you have to draw. Plus, this is the most important diagram. This is called as temperature enthalpy diagram. Okay. Now I'll explain once again this diagram. So you have to take temperature as y coordinate and enthalpy. Enthalpy is heat content of the system, and it is given by the formula H equals to U plus PV. Okay, and another formula is MCP into delta T. This two formulae you should remember. Enthalpy is U plus PV, and another formula is MCP delta T. Okay, that is the enthalpy. So we are going to start from the 0 degrees Celsius. Okay, whenever the water enclosed in a closed cylinder bounded by a piston is heated, okay, then the temperature decreases. Slowly, there will be change in the phase takes place. Okay, when it reaches 100 degrees Celsius, okay, so that point temperature is called as the saturation temperature, and the whatever the heat you can see the clearly you have to show sensible heat. Okay, sensible heat. So it is a portion between A and B. Okay, the definition of sensible heat is okay, sensible heat is the amount of heat required to change the temperature of 1 kg of water from 0 degrees Celsius to saturation temperature. Okay, so based upon diagram only you can define. Okay, it is the amount of heat required to change the temperature of water which is initially at 0 degrees Celsius to saturation temperature, that is 100 degrees Celsius. That is called as sensible heat. Okay. So when it reaches point B, then once again we are going to supply the heat to that closed vessel. Okay, this is a diagram already explained in the previous class. Okay, these are the 5 diagrams. So initial, it is at 0 degrees Celsius and atmospheric pressure. Okay, next we have to supply the temperature. We have to supply the heat to the steam. Okay, we have to supply the heat to this steam. There will be no change in temperature, remember, but whatever the amount of the water particle presents completely converted into the dry saturated steam at point C. Okay, so the portion BC is called as latent heat. Okay, then how to define the latent heat? Okay, the amount of heat required to convert 1 kg of water at 100 degrees Celsius to 1 kg of dry saturated steam at same temperature and at a given pressure. That is called as latent heat. So this diagram is most important diagram. Okay. So first you have to draw A, then B, next C, okay, next D. Okay. So one is P equals to constant. Okay, everywhere there is no change in pressure. P equals to constant. Okay, so you have to write this diagram. So whatever first temperature is your 0 degrees Celsius, second temperature is your saturation temperature, and the third temperature is your superheated temperature. Okay, between the portion AB it is sensible heat. Okay, and between portion BC is it is latent heat, and then summation of sensible heat is represented by HF, latent heat is represented by HFG, and total heat what I have shown in the steam table is HG. It is a summation of HF and HFG. Then so when you heat the steam, it is we are having dry saturated steam. When you heat the steam above 100 degrees Celsius, then the temperature of the steam rises. Oh, and this is called as the superheated temperature. Okay, superheated temperature is the temperature above the saturation temperature. Okay, and I gave one definition called as degree of superheat. Degree of superheat is it is the difference between superheated temperature minus saturation temperature. Suppose superheated temperature is around 200 degrees Celsius and saturation temperature is 100 degrees Celsius. Then degree of superheat is 210 minus 100. This is 110 degrees Celsius. So this is the most important diagram. So every time they used to ask this enthalpy temperature diagram. So only 3 lines are there. So 2 inclined lines and 1 horizontal line. So you have to show all the parts properly. First one is sensible heat, second one is latent heat, and third one is a total heat and amount of superheat. Amount of superheat is it is the amount of heat required to convert 1 kg of dry saturated steam into 1 kg of superheated steam. Okay, so this is the temperature enthalpy diagram. Okay, now we'll discuss some types of steam. Okay, already stated there are 3 states of steam. One is wet steam, second one is dry steam. It is also called as dry saturated steam, and third one is called as superheated steam. Okay, then how we are going to define wet steam? Okay, wet steam is a mixture of liquid and water particles. Okay, so steam of saturation temperature, it is a axial state and it is at saturation temperature. It is just mixture of liquid and vapor particles. Okay, so whenever steam contains the liquid water particles in suspension, such kind of steam is called as a wet steam. Okay, second one is dry steam. It is also called as dry saturated steam. So dry saturated steam does not contain any water particles in suspension. Okay, and the temperature of the steam is at saturation temperature. Okay, and third one is saturated steam. Okay, saturated steam and dry saturated steam both the same. Okay, third one is superheated steam. Okay, superheated steam is when the steam is heated beyond the saturation temperature, that is above 100 degrees Celsius. Such condition of the steam is called as superheated steam, and it is at superheat temperature. So these are the 3 types of steam. Next, steam properties. Okay, steam properties. You are going to learn some definition of steam. First important definition is called as dryness fraction. Okay, dryness fraction. It is also called as quality of steam. Okay, quality of steam. It is defined as the ratio of mass of dry particles present in a known quantity of wet steam. It is defined as dryness fraction. Okay, so it is a ratio of mg divided by mg plus mf, where mg is how much amount of the mass of the dry particles present to the total mass of this wet steam. Okay, total mass is mass of the dry particles plus mass of the wet particles. Okay, it is a ratio of the dry particles present in a wet steam to the total mass. That is called as dryness fraction. Okay, so we are having the formula mg divided by mg plus mf. Okay, we are having the various instrument to measure dryness fraction, like we are having separating calorimeter, throttling calorimeter, combined separating and throttling calorimeter. So we are going to discuss those description in the next class. Okay. So before that, first you have to analyze the terms properly in the steam. Okay. X represented by symbol X. Okay. When X is exactly 1, so that is called as dry saturated steam. Okay. So where the mass of the wet particles is not there, that is will get mg divided by mg. So X is 1 in case of dry steam or dry saturated steam. Okay. And in case of the wet steam, what is the value of X? Can you tell me? What is the value of X for wet steam? It is less than 1 or exactly 1 or greater than 1.
Less than 1, sir.
Correct. So it lies between 0 and 1 for wet steam. X is exactly 1 for dry steam or dry saturated steam. So one of the important definition in steam. Okay, you remember dryness fraction is defined as the ratio of the dry particles present to the total mass of the wet steam. So the total mass is nothing but the summation of mass of the dry particles plus mass of the wet particles. Okay. So in the exam, so they'll ask identify whether it is a dry steam, wet steam, or superheated steam. So you have to find out dryness fraction. If it is less than 1, you have to tell it is wet steam. If it is exactly 1, you tell it is wet steam. Sorry, it is the dry steam. If it is greater than 1, it is the superheated steam, like that. Okay. Next, saturation temperature. So in this steam tables mainly concentrate on the definition. Saturation temperature. Okay. So boiling temperature is also called as the saturation temperature or the formation of the steam. Okay. Saturation temperature. 100 degrees Celsius is the boiling temperature of the water. It's nothing but saturation temperature of water. Okay. Third definition is sensible heat. Okay. As we discussed, the portion between A and B is the sensible heat. This is the first part. Okay. Sensible heat. Sensible heat definition is the amount of heat required to change the temperature of 1 kg of water. You remember, at 0 degrees Celsius to saturation temperature. How much amount of heat required to change the temperature of 1 kg of water, which is initially at 0 degrees Celsius, to 1 kg of water at saturation temperature. It is represented by symbol HF. Okay, remember, sensible heat is represented by symbol H suffix F. Second one is latent heat. Whatever the portion between B and C, so B and C. So when you supply the heat, there will be no change in the temperature. Okay, the temperature remains same, but all the water particles present in the wet steam completely converted into the dry saturated steam. Okay, that is called as latent heat. So in terms of definition, it is defined as the amount of heat required to convert 1 kg of water at saturation temperature into 1 kg of dry saturated steam at the same temperature. You remember there is no change in temperature during latent heat, and there will be a complete conversion of the water particles into the steam. So the amount of heat required to convert 1 kg of water at saturation temperature to 1 kg of dry saturation steam at the same temperature and at the given pressure, and it is represented by symbol HFG. Next, total heat is, it is a summation of latent heat and sensible heat. Then in terms of definition, so you have to take, for total heat, you have to take the portion between A and C. Between A and B, sensible heat. Between B and C, it is the latent heat. Between A and C, it is the total heat. Okay, and then how you are going to define the amount of heat required to convert or to change the temperature of 1 kg of water at 0 degrees Celsius to 1 kg of dry saturated steam at 100 degrees Celsius and at the given pressure. So you have to remember between A and C, the amount of heat required to change the temperature of 1 kg of water at 0 degrees Celsius to 1 kg of dry saturated steam at 100 degrees Celsius and at the given pressure. That is a total uh, heat of evaporation or total heat. Okay. It is a summation of sensible heat and latent heat. Okay. Superheat. Okay. Superheat is amount of heat required to convert 1 kg of dry steam into superheated steam. That is called amount of superheat. Superheated temperature. Okay. So saturation temperature is boiling point of the water, and superheated temperature is when you heat the steam, dry steam, above the saturation temperature. So that temperature is called as superheated temperature. Okay. It is above saturation temperature. Degree of superheat. The difference between superheated temperature and saturation temperature is called as degree of superheat. Okay. So T sup minus Ts. Degree of superheat. Okay. Next term is enthalpy of steam. Okay. So enthalpy is already studied in first law of thermodynamics. Enthalpy is given by H equals to U plus PV. U is internal energy of the steam, P is pressure, and V is the volume. By knowing these three values, we can find out the enthalpy of steam. Okay. So once again, we are having the enthalpy of three steams. One is enthalpy of dry steam. So first you have to define the term. Enthalpy of dry steam is defined as the amount of heat required to convert 1 kg of the water, which is at 0 degrees Celsius, to 1 kg of dry saturated steam at saturation temperature. Okay, that is called as enthalpy of dry steam. And we know that the total heat is given by, or total enthalpy is given by Hg equals to Hf plus X into Hfg, as X is exactly 1 in case of a dry steam. So you can take X as 1. So after taking X as 1, we can write it as Hg equals to Hf plus 1 into Hfg. It's nothing but Hf plus Hfg, because X is exactly 1 in case of uh, dry steam. Okay. So enthalpy is amount of heat required to convert 1 kg of water at 0 degrees Celsius to 1 kg of dry saturated steam at saturation temperature, and represented by symbol Hg. Okay. Similarly, we have the enthalpy of wet steam. Okay. How we are going to define enthalpy of wet steam is, you have to take X into consideration here. Okay. Dryness fraction into consideration, because the wet steam contains the water particles in suspension. Okay. So how we are going to define it is the amount of the heat required to convert 1 kg of the water at 0 degrees Celsius to 1 kg of wet steam at saturation temperature. That is the definition of enthalpy of wet steam. Very simple. Amount of heat required to convert 1 kg of water at 0 degrees Celsius to 1 kg of wet steam. This is important. At saturation temperature and at the given pressure. Okay. And the formula for enthalpy of wet steam is H wet. So here first you take G, and here you have to represent it as wet. H wet equals to Hf plus X into Hfg, because we get the value of X is less than 1, you have to consider dryness fraction into account in case of wet steam. So, and it lies between 0 and 1. The formula for enthalpy of wet steam is Hf plus X into Hfg. Okay, kilojoules per kg. The second this one, enthalpy of wet steam. Next, enthalpy of superheated steam. Okay, so enthalpy of superheated steam is it is the amount of heat required to convert 1 kg of water at 0 degrees Celsius to 1 kg of superheated steam at superheat temperature. Okay, you see the diagram. So you have to take between the points A and D. That is last one, HF, super, means the amount of heat required to convert 1 kg of water initially at 0 degrees Celsius to 1 kg of superheated steam at superheat temperature. Okay, that is the enthalpy of superheated steam. So we learned three steams like dry steam, wet steam, and superheated steam. Based upon that one, we are having the three enthalpies. One is enthalpy of dry steam, enthalpy of wet steam, and enthalpy of superheated steam. You remember, the enthalpy of superheated steam is given by the formula H super equals to HF plus HFG. You have to take plus apart from these two terms, you have to take one more term. CPS into TS, T superheated temperature minus TS. So first you have to take sensible heat plus latent heat plus degree of superheat multiplied by specific heat of the steam. This is the formula for enthalpy of superheated steam. HF latent heat plus HFG. So HF is sensible heat plus HFG is latent heat plus CPS is specific heat of steam. Okay, remember the value of specific heat is given by 2.25. Sometimes they will give 2.25 in the problem. Otherwise, you have to remember. Okay, it's one more term you have to remember in the steam. That is CPS, specific heat of steam is 2.25. How we learned CP and CV in module 2 and 3. CP is specific heat at constant pressure, that is 1.005. CV is specific heat at constant volume, that is 0.718, like that. Here in this chapter, we are going to study specific heat of superheated steam, and it is above our normal value. It is always 2.25 to 2.3. Better you remember 2.25. This is the specific heat of superheated steam into superheated temperature minus saturation temperature. Okay, superheated temperature is above 100 degrees Celsius and saturation temperature is 100 degrees. So HF plus HFG is nothing but our total heat of evaporation. Okay, instead of HF plus HFG, directly you can take HG plus CPS into superheated temperature T sup minus TS. Okay, this is the formula for enthalpy of superheated steam. So these three formulae you should read. First one is dryness fraction, that is mg divided by mf plus mg. Second formula is hg is hf plus hfg for dry steam. H wet is hf plus x into hfg. Okay, where x is mg divided by mg plus mf. And third one is h sup, that is superheated enthalpy is hf plus hfg plus CPS into T sup minus TS. Okay. These are the formulae related to enthalpy. Remember, as I said, definition are the most important. Try to analyze the definition. Once you analyze the definition, easily you can solve the problem. So problems are very simple. Just you are referring the steam table and substituting in this formula. That's it. Okay. And next term is specific volume. What you observed in the steam table is specific volume. So already we studied the unit of specific volume is meter cube per kg. So in terms of definition, the specific volume, the definition of specific volume is the volume occupied by 1 kg of substance is called as specific volume. So general definition. Okay. So unit of specific volume is meter cube per kg. Next, we are having the specific volume of saturated water. So based upon this one, we are having certain definition related to specific volume. First term is specific volume of saturated water. Okay, it is the volume occupied by 1 kg of water at saturation temperature and at a given pressure. Okay. So based upon this term only you can define. It is a volume occupied by 1 kg of water at saturation temperature and at a given pressure. Okay. Next, specific volume of dry steam. Okay. So how we are going to define specific volume of dry steam? It is a volume occupied by 1 kg of this is a wet steam. Specific volume of wet steam is defined as the volume occupied by 1 kg of wet steam at a given pressure is called as wet steam. Okay. So volume occupied by 1 kg of wet steam is called a specific volume of wet steam. Okay. And the formula for specific volume of wet steam is X into Vg. You should remember. So wherever wet steam comes into picture, you have to take the X into picture. Okay, X into Vg. It is a specific volume of wet steam, product of dryness fraction, and Vg. Vg is specific volume of dry steam. That is called as specific volume of wet steam. Okay, and for specific volume of dry steam, directly you take Vg. Okay, because X is 1. Okay, whenever wet steam is, just you multiply by dryness fraction. Okay, so first one is specific volume of dry steam is Vg. Specific volume of wet steam is X into Vg. And third term is we are having the specific volume of superheated steam. Okay. So it is a volume occupied by 1 kg of superheated steam at superheat temperature. Okay. And at given pressure. Okay. Just you remember condition of pressure and temperature. It is a volume occupied by 1 kg of superheated steam at superheat temperature and at a given pressure. Okay. So remember, in all the cases, the pressure remains same. There is no change in pressure. Okay. So only the temperature changes, the enthalpy changes, and entropy changes. And it is denoted by V sub. Okay. So we can define, we can compare with a dry steam. Okay, so Vg by Ts equals to V sub by T sub, like that we can write. So Vg divided by Tg, that is specific volume of dry steam, divided by saturation temperature equals to V sub, that is specific volume of superheated steam divided by T sub, means it is superheat temperature. So based upon that equation, we can write it as V sub. It is nothing but specific volume of superheated steam equals to Vg, that is specific volume of the dry steam, into T sub divided by Ts. Okay, so using this equation, we can find out the specific volume of superheated steam. So these are the things I should remember, and one more is that is internal energy of the steam. Okay. Now I'll solve. So sometimes they may ask, what are the advantages of superheated steam? As I said, we cannot use the dry steam in the steam turbine plants, so we have to use superheated steam. These are the few advantages. Superheated steam can be used in the power generation in steam power plants due to more heat content. As I said, because it is heated above the saturation temperature, because of the more heat content, so we'll get the more power generation. Hence, superheated steam is preferred in steam power plant. Okay, as heat increased, so it increases the efficiency of the boiler. Okay, and efficiency of the device, and it increases the life of turbine blades as it does not contain the water particles and hence avoids the corrosion problem. Because of the supply of the superheated steam, it increases the life of turbine blades as it does not pose the corrosion problem. Okay, and on the other hand, we are having disadvantages also. The cost of production is high. The lubrication is a problem in case of superheated steam. So this is a difference between dry steam and superheated steam. Sometimes they may ask, okay, differentiate between dry steam and superheated steam. First difference is heat content will be less. Second one is heat content will be more. Okay, and here the corresponding temperature with respect to dry steam is dry saturation temperature, that is Ts, and whatever the corresponding temperature with respect to superheated steam is superheated temperature, and cannot be used for power generation. As I say, dry steam still contains the water particles, so will not get the 100% this one dry steam. Still there will be some water particles will be there, hence it is not good for supplying to the steam turbine blades. So always they prefer superheated steam, that is it can be used for power generation. Cost of the production is less. Here cost of production is more. Okay, in terms of cost. And then there occurs condensation problem. Already we studied 3 modes. One is condensation, sublimation, and evaporation. Evaporation means change of phase from liquid to vapor. Condensation is change of phase from vapor to liquid. Sublimation means change of phase from directly solid to vapor. Okay. So there will be condensation problem and there will be no condensation problem because it is completely superheated. Okay. Now I'll solve these are the problems how they'll ask in the exam. So concentrate on the problems. Okay. You see the first problem, first simple problem. Determine the dryness fraction of steam if 2 kg of the water is in suspension with 80 kg of dry steam. So this is the first problem. We have to find out what is the dryness fraction of the steam. First thing is you have to write the given data. Given data is mf equals to 2 kg. Is the mass of the water particles in suspension. And mg is 80 kg. It is the mass of the dry particles in the given stream. So one is mf and one is mg. According to our definition, dryness fraction x is the ratio of uh, dry particles to total mass. Dry particles is 80 divided by 80 plus 2. So 80 divided by 82 is 0.975. Less than 1. So it is a wet steam. Okay, like that we can analyze. Second problem, 10 kg of wet steam contains 1.75 kilogram of water particles in suspension. What is the dryness fraction of the steam? Okay. See, 10 kg is your total mass, 10 kg. And mass of the water particles is 1.75 kg. Then what about dry particles? Mass of the dry particles is nothing but 10 minus 1.75. So 8.75 kg. In the previous problem, directly 2 kg of water particles in suspension is given, but in this problem, dry particles not given. So you have to find out the mass of the dry particles that is in suspension. So 10 kg is the total mass, is nothing but mf plus mg, that is 10 kg. Next 1.5 kg is mass of the water particles represented by mf. Then mg is 10 minus 1.75. So 8.25 kg is the mass of the dry particles present, dry steam present in the wet steam. So dryness fraction is given by mg divided by mg plus mf. Mg is 8.25. Don't take 10. You have to take always the mass of the dry steam, 8.25 divided by 10. So 0.825. Another name for dryness fraction is quality of steam. Sometimes they may ask, find out the quality of steam. Okay, quality of steam is 82.5%. Whatever dryness fraction you are getting, you have to multiply by 100. So dryness fraction of the steam is 82.5, or quality of the steam is 82.5%. Okay. Next important problem, such kind of problem we'll ask. You see, the problem number 3 is important. Find the enthalpy of 1 kg of steam at 12 bar pressure when there are 3 conditions. So how much enthalpy is required for 1 kg of steam which is at 12 bar pressure when the steam is dry saturated? Second one is steam is 22% wet, and third one is it is superheated at 250 degrees Celsius. Assume that specific heat of superheated steam is 2.25 kilojoules per kg Kelvin. So in this problem, specific heat is given, otherwise you have to assume it as 2.25 kilojoules per kg Kelvin. Okay, as I said, here it is pressure. You have to refer pressure based table in the steam tables. Go to the pressure base table. Okay, so at 12 bar pressure, find out the properties. Okay, as I said, in the second column only you are getting the temperature as 188 degrees Celsius. Okay, go through steam tables and find out. Okay, at corresponding to 12 bar pressure, okay, we are having two tables. One is temperature based, it is first table, and pressure based table. Go to first column. In that case, go to 12 bar value. Okay, then just you find out the properties from the table. So TS is 188 degrees Celsius, HF sensible heat is 798.43 kilojoules per kg, and HFG is all the values are there in the steam tables corresponding to a pressure of 12 bar. Okay, see, suppose if it is a 10 marks question, 2 marks for finding out values only. Directly, suppose just you write the values, you'll get directly 2 marks. Okay, remember that's why. So analyze steam table properly. Just you see the values and put the values. Next, you have to find out what is the enthalpy of dry steam. Enthalpy of dry steam is, as I said, HF plus HFG. Okay, just you add 798.43 plus 1984.3. So you'll get 278 2782.7 kilojoules per kg. This is the enthalpy of 1 kg of dry steam. HF plus X into HFG, where X is 1. So directly you take HF plus HFG. You get 2782.7 kilojoules per kg. Then what is enthalpy of wet steam? So a given steam is 22% wet. Okay, 22% wet means don't take 22%. You have to take 100 minus 22. Means how much dryness fraction? That is 100 minus 22 is 78% dry. Means dryness fraction is 0.78. Like that you have to take. Whenever they'll give some 20% like that, just 100 minus of that value, you get 80%. The dryness fraction is 0.78. Okay. So don't take 0.22. Suppose you take 0.22 wrong. So you have to take 100 minus 22. That is 78%. That is dryness fraction is 0.78. You have to convert in decimal. You have to put value of X is 0.78. Next, you have to substitute the formula. So H superheated equals to HF plus X into HFG. So already you take the value of HF from the steam tables, and only you have to add is X, that is dryness fraction. Okay. So 798.43 plus 0.78. This is into your HFG. Okay. So you'll get 2364.18 kilojoules per kg. And third formula is how to find out the enthalpy of superheated steam. Okay, that's why I said you have to remember the formula. This is Hg plus Cps into T sup minus Ts. Hg is total heat. Already we found out as 2782.7 plus Cp is 2.25 given in the problem. Otherwise, you have to remember this value into 2 sup. T sup is 250 degrees Celsius given in the problem minus Ts. Ts is saturation temperature. We are finding out from the steam table. So we are getting enthalpy of superheated steam as 2922.2 kilojoules per kg. Now you compare all the three values. Okay. So obviously you'll get more value in case of superheated steam because amount of the heat is more. So like that you can analyze 2922.2 kilojoules per kg is enthalpy of superheated steam. 2364.18 is your enthalpy of wet steam, and 2782.7 is the enthalpy of dry steam. Okay, first value is enthalpy of superheated steam, second value is enthalpy of dry steam, and third value is 2364. Okay, so like that you can compare the values and you can analyze whether your answer is correct or not. Okay, so first highest value is your enthalpy of superheated steam, second highest value is your enthalpy of dry steam, and last one is your enthalpy of your wet steam. Okay, so this is how to solve the problem. Same kind of problem is there. Okay, I'll solve one problem on specific volume. Okay, so I solved one problem on this one enthalpy. Here I'll solve one problem on a volume, specific volume. Okay, so see problem number 7. Determine the specific volume and density of 1 kg of steam at a pressure of 7 into 10 to the power of 5 Pascal. It is nothing but 7 bar. When the condition of steam is wet, having dryness fraction 0.9, second one is dry, and third one is superheated at 250 degrees Celsius. If required, use the steam tables provided below. Okay, so once again you have to refer the pressure base table. At 7 bar pressure, go to the steam table, refer the steam table. At corresponding pressure of 7 bar, we're finding out saturation temperature as 437.92 and volume as 0.27. So when first condition, very simple formula, when the steam is wet having dryness fraction 0.9, just you multiply by x into Vg. X is 0.9 given in the problem, and Vg what you are finding out from the steam tables. Just you multiply, you will get the specific volume of the wet steam. When the steam is dry, what you are going to take? Directly you take x as 1. Okay, 1 into Vg, that is 0.246. Whatever value is given in the steam table, same value you have to take. Okay, that is nothing but 0.277 into 1. You will get 0.277 only. It is a specific volume of dry steam. Then how to find out specific volume of the superheated steam? Okay, as I said, you have to use this formula: Vg into T sup divided by Ts. Vg is what? 0.273341. Okay. Into superheated temperature is how much they are given? That is superheated temperature is 250 degrees Celsius. As I said, you have to convert all the temperature in Kelvin units. Okay, 250 plus 273, 523 Kelvin. Ts is once again you have to convert in Kelvin. Ts is 437.92. This is from steam table, you remember. Okay, 437.92 Kelvin directly given in the problem. No need to convert. Okay, so 437.92 Kelvin. So after substituting, you get 0.3264 meter cube per kg. Then how to find out the density? Okay, density is we know that specific volume is meter cube per kg, and density is reciprocal of specific volume. Already you know density is kg per meter cube. When you reciprocate the specific volume, you will get the density. Just you take 1 divided by this specific volume. 1 divided by 0.3264. You will get 3.063 kg per meter cube. This is the density of our superheated steam. Similarly, you have to find out the density of wet steam as 1 divided by 0.246. You will get the density of wet steam. Similarly, you have to find out the density of dry steam as 1 divided by 0.27. Okay, you'll get 3.66 and this is 3.06. So like that, we can find out. You remember the relationship between specific volume and density is given by density equals to 1 divided by specific volume. So like that. So first you should know all the definition, then how to see the values in the steam tables, and then remembering the formula we have to find out. You remember one problem carry 10 marks. Okay, so you have to first find out the properties important. So properties only carry some marks. Okay, and remember the formula. Okay, so understood how to see the steam tables. Any doubts? Yes. Concentrate mainly on the terms and formula and how to see the steam tables. Okay, I have already shared the steam tables in the Google Classroom. Just go through it. Okay, and just try to solve the problems.
These problems are there in the test, no, sir? The
It's
steam
there.
problem.
Steam problems is there. That's why. Okay, if you have any doubts, okay, that's why. Because in the thermodynamics, it carries both the numericals and theoretical part. Yeah.
Yes, sir.
That's why I'm giving some simple problems. Whatever I taught today, same kind problem.
Okay, sir.
Simple problems I give. Okay, just that's why I said try to understand steam tables. So, if you are having any doubts, please ask me. Okay, I'll clarify and I'll try to solve the problems. Okay, I hope you understood all the concepts.
Okay, sir.
Okay. Okay, I'll stop the session now. Okay. Tomorrow we'll meet.
Thank you, sir.
Thank you.